points. So if someone could get me a cortado, I would adore you.
You would get serious Tommy points.
I do. So much.
All right. It's 9:30. Let's go ahead and get started. This is the HTTP working group. This is our only session in this IETF. I think that's the first time we've done that for a while. So things are a little, not slowing down, just a little more compact. We have a scribe selected. Thank you, Sean, for your generous and magnificent service. To the note well? Yep. See if the clicker, oh yeah, the clicker, thank you. Yes, so this is the note well slide. It's a little different this time if you haven't seen it yet. This is the policies under which we all participate in the IETF. And we want to especially draw attention to the aspects of it regarding professional behavior and the code of conduct and the anti-harassment policy. This is important. We expect folks to behave professionally. We expect people to contribute constructively. If you have any concerns around this, please come talk to Tommy or myself or to the area director, Mike. Mike, say hi. Mike's here. And or other leadership folks. We do take this serious. We want to build a good culture where people feel enabled to contribute. And part of that is making sure we treat each other well. Also, likewise, the contributions you make here, whether in writing or at the microphone or whatever, are covered by the different policies regarding intellectual property. Make sure you're aware of those, especially regarding patents, and if you write things, copyright as well. We are following the Internet Standards process that's documented in a couple of different RFCs, which are currently under revision. So make sure you're aware of those. That's how we do things. And finally, we do record these sessions. And so be aware of that from a privacy standpoint that we're gonna distribute photographs and recordings and so forth about these meetings. Any questions? Talk to Tommy and myself, or to Mike, or to other leadership folks. So our agenda today is that we're going to first talk about the active drafts we have. The group has a number of drafts in the advanced stages, either at the RFC editor or with the ISG, or just finishing up working group last call. But we're going to talk about the ones that are still in flight, as it were. And then we have a few other topics that people have brought up. Any agenda bashing? I think, oh, now I forget. Someone had asked to go later.
I think Eric.
No.
No.
Oh, yes.
The secondary search, we're going to move that later.
That's right. We're going to move secondary search later. No.
Ben, I see you're in queue. Ben, do you want to come up? Hey, Ben.
Hi. I didn't expect to be available at this time, but I am. And if there is time, it would be nice to discuss the Connect TCP reset handling PR that's open.
How long do you anticipate that needing? Just like 5 or 10 minutes?
Yeah.
Okay. Maybe just start with that, just to.
Sure.
Yeah.
Sure. Yeah.
It was originally on the agenda.
Yeah. So that was on the agenda that we thought you weren't available. So yeah, I think that's fine to actually, if you're ready, you could take that first. And would you be able to share anything that you want to show on the screen?
I will try that.
Okay. All right. Any other agenda bashes, let us know, but I think we'll get started here then. Granting permission. No. Yes, grant there.
Okay. How's the screen share?
We can see it.
Okay. So this is I believe the last open PR for the Connect TCP draft, at least the only currently open PR. And it is fundamentally about how we translate between TCP connection failures and signals that go over the HTTP streams that represent that TCP connection. And in particular, there's some very tricky questions about the behavior of half-open streams during shutdown. So TCP has the idea that either side can close its send stream with a TCP fin. That doesn't mean that the connection is over. So if I send you a fin, you can continue to send me data. The TCP specification also says that you're supposed to be able to tell whether I received all of your data. That is signaled by FINAC. And so this PR defines a way to basically translate the FINAC or lack thereof, and in particular says that if you are in this situation where you have where you've sent data and you need a way to learn if it's been received or not, the way we signal that is with a stream error in HTTP 3 or HTTP 2, but HTTP 1.1 doesn't have stream errors. So to create an analog for stream error, the PR says you should use a TCP shutdown without a closure alert, which is the official term for what we usually call in TLS a close notify. This is all at the should level. So mostly because we know that, especially in HTTP 1.1, it can be hard to mess with this layer. It can be hard to get to mess with the TLS shutdown behavior. And so, and this is not critical, right? If you get this wrong, then maybe you will turn some clean shutdowns into abrupt shutdowns or vice versa, but you won't actually lose any data or break most applications. So this is a proposal that has been batted around a lot. We've been talking about this version since July. A lot of folks have reviewed it. Some have marked approvals, and some have raised some additional concerns. In particular, Martin Thompson has been presented some alternative views here. So I want to see if we can close this out.
Okay, I think I believe we do not have Martin in the room, but we would appreciate if others have opinions or thoughts here, if we can provide some input on this, or if there are clarifying questions on things that we can ask to help us make a decision as a group.
Should we go?
All right. Alan.
Alan Frindell. So, Ben, I'm sorry I have not seen your PR until now. All I know is that messing around, like, are there a lot of protocols people are trying to run over Connect TCP that rely on half close in a way that is reliable? Because we sort of know that HTTP itself, when it's running this way, doesn't really work super well with half close. And so, like, how critical is it that we get this like perfect?
Yeah, so I think it's not, and that's why this is a should. So I think it is valuable for us to define a way to do this right and say, look, if you're in some situation where you really care about this, this is the procedure. You have to do this. You have to dig into your TLS library and figure out a way to like make sure that it does or doesn't send close notify. You have to dig into your H2 and make sure that it does or doesn't send a stream error. If you don't care, and most people don't care, then you're not going to follow the should. It's debugging is going to be a little harder, but it'll still work. In the 95% case, it's fine.
yeah, I mean, at least the HTTP stack or the TLS stacks that I work with have found like very limited support at the TLS layer for the concept of half close. Like sometimes I get like an event loop where I can actually write but not read, or vice versa. But then that disappears rapidly, and so I don't know that without, like you're saying, like I have to do a lot of spelunking to implement this in any kind of way that, like, I don't know, I don't want anyone to use HTTP 1.1 anyway. Like, so
Yeah. So So part of the story here is like this is the text here is a should across all the HTTP versions. And in H3 and H2, I think this is basically not very controversial to say, like, you got a reset, you send an error to indicate the reset. That's actually the same guidance that's already present for Connect in those HTTP versions. So what's happening here is, for parallelism, this PR is trying to like define. We already had a definition that said you should send an error alert, right? What the PR is doing is changing that from saying send an actual error alert in TLS to something that seems to be a lot easier, which is saying just kill the TCP connection without a close notify. But either way, yeah, this may not always be implementable, which is why it's
okay. I think I understand the proposal. I'm not sure I have any more to say.
I joined the queue just as an individual here. So, Ben, what you're saying made me think. So, like in the H3 and H2 case, you're following what would happen for Connect, right? Because this is already defined. So, is there an option here of just leaning on anything that is said or not said for HTTP 1's handling of Connect closure? Like, is there a reason that the TCP Connect that we're defining here for H1, which I imagine is a pretty small part of the use case here, I think a lot of people are going to be doing different versions. Does it need to be any better at closing than existing Connect? Or can we essentially just say, this is what has been done in practice and what is defined?
in my
Take it
experience,
as what it is.
in my experience, gateways often end up doing version translation between with an HTTP 1.1 step somewhere in the chain that processes your request. So I think if we want the H2 and H3 behaviors to be widely implementable, we need to define a matching HTTP 1.1 behavior. Otherwise, you'll get a gateway that has to translate to HTTP 1.1, and it, for example, receives an H3 stream error, and is like, how do I represent this H3 stream error in HTTP 1.1 to propagate this correctly across versions? I don't think that we need every implementation to do that, but I think we should define a clear way to do that for people who care. I don't think it costs us anything.
Sure. And I guess to clarify then, because that is a problem you could have today with current Connect proxies that are using H2 or H3 that may have something in the back end, which,
Yeah,
I mean, I think oftentimes you do have just pure H2 and H3 Connect proxies for certain cases, but in those other cases, like, are we trying to position this as Connect TCP via saying these shoulds will have a better time than just using plain Connect? Because you
so
could
I
also
do
take the approach of like generically for Connect translating shutdown, you could have it. It doesn't need to be just this specific submethod.
So my understanding is that HTTP Connect is essentially defined today in the HTTP semantics draft, which is version independent, and in the H2 and H3 draft RFCs. But there is no specification of HTTP Connect in HTTP 1.1 specifically, at least not in any great detail. And I don't remember any language that really talks through the details of how shutdown works and how half close is supposed to be handled. So yes, I do think this is also an opportunity for us to get a little bit more specific about behaviors here and make this all a little bit more seamless than the pre-existing connect. But again, this is a should. And also we have this other language that says, please, like you don't use HTTP 1.1. We essentially have a should. If you're using HTTP 1.1, you should do this. And also you should not use HTTP 1.1.
Yeah.
So anyway, I think I just want to notify the group that we're in a holding pattern on this PR right now. And I think this is kind of the last change that's potentially holding up the draft. So I want to get us unstuck and move forward on this.
Thank you. Okay, so let's, if people can give some eyes to the PR, add comment suggestions there, we'll try to follow up with Martin as well.
That sounds good.
All right.
Good.
Thank you.
We can. Would anyone please raise your hand if you're willing to help take a look and unstuck us so we can move forward?
Yeah.
Kazuho, thank you. Lucas, Alan, yep.
Yeah.
All right. Great. So just please provide your input and we'll try to get this moving so we can ship this document. Thank you.
I think there's already been a
Yeah.
decent group of
Yeah,
people.
this is good. This is good. This is good.
Okay, so next we have resumable uploads. Marius, remote.
Yes.
And now with the slides.
Yep.
All right. Hello, everybody. I hope you can hear me all well. Please let me know if that's not the case. I want to provide a brief update on the resumable upload draft, as well as discuss some of the remaining open issues that we have to bring this draft forward. After the last IETF meeting, we started a working group last call and got a lot of detailed feedback from many individuals, especially from Mike, Glenn, Willie, and many others. So thank you very much for all of the feedback. That was really helpful. We integrated already a lot of the feedback into the latest draft version that we have. That includes numerous editorial improvements as well as some normative changes. Especially around security considerations, relaxing requirements that were too strict, but also reusing mechanisms like the accept patch header field to communicate support. At the last IETF, I proclaimed that we had no open issues and no open pull requests. That's unfortunately no longer true. We have 28 open issues. 10 of them are just editorial that we're going to work through as editors. But there's 4 especially that need discussion and that I would like to spend the time on to see if we can continue with them. The first one is one that has come up a few times before, and that is about retrieving lost responses after an upload was completed. Resumable uploads offer great support for resuming from interruptions that happened during the upload. But once the upload is complete, there is a certain failure case that is troublesome in reality. So if the client completes the upload, but is not able to receive the final response because there was a network interruption, it is not able to recover this lost response. There are some workarounds to this. If the upload resource is still available, you can send a head request and maybe the response will include some header fields that provide you with the necessary information. But this is more a workaround than really recovering the lost response. And this is a point that we have received feedback on, that existing implementations and deployments of resumable uploads really struggle with this. So this isn't some theoretical issue that we think about, but this is feedback we've received from current deployers about this. So we think it would be great if we could offer some improvements over the current de facto. And one of the proposals that we've been kicking around and that I want to present now is that once the upload is complete and the final response has been generated, that the server should cache this response as long as the upload resource is still available. This duration depends very heavily on your application. That might be a few seconds, that might be a few minutes, maybe an hour. That is completely application dependent, but is communicated through existing limit headers. But this cache would then give the client the ability to refetch this lost response through an empty patch request. This mimics the behavior how the upload is usually completed, giving the client the ability to refetch the final response in a way that requires little to no additional logic on the client side, while also removing one of the error cases that we've seen that servers have to implement. So it would integrate quite well with the mechanisms we currently have. And on GitHub, we've seen quite good support for this proposal from people who are currently implementing resumable uploads. But I want to bring this to the working group here right now and get feedback on this, whether you see something completely speaking against this proposal, or if there's feedback in favor of it.
Alan Frindell. So I'm curious here what happens when the server is actually a VIP and there's like a million upload servers behind it, and which server is cached this thing, and how that routing works, and is it expected to work in the same way as if you were talking to a single server with an in-memory cache of the thing that it just did?
Yes. So in practice, this would be routed to whatever server is holding the upload resource. This is usually identified by the upload resources URL. So that would be routed to the same server. And this server has to store some state of the upload resource, basically how much data has been uploaded and if it's complete or not. And that would also be where then this response would be cached. Of course, the application developer should make sure that the response is as small as possible to reduce footprint.
Alessandro Ghedini, Cloudflare. I think maybe the word cache is not the correct one, because like in theory, the server could just generate the response from scratch, knowing the state of the upload, right? So I don't know what the actual wording is, but maybe just saying the server should just resend the final response if the client asks for it, rather than talking about caching.
Yes, thank you. That's very good feedback. Of course, they could either cache it or regenerate it, whatever it works best for the application. That's good feedback. Thank you. Austin.
Hello, Austin Wright, partial content enthusiast. I know everyone would like to solve this problem sort of intuitively, but I feel like this is the same class of problems if I make a post request, like to book a flight or something, and that has to run a long time, like several minutes, and then I miss the response to that. I feel like a generic solution to this problem would also cover just post requests. And maybe that should be, maybe this doesn't need to be solved, but there can be a separate solution that's proposed separately.
Hi, Ben Schwartz. There's something slightly funny about doing this with a zero-length patch request. Zero-length patch strikes me as a little bit like the Unix touch command, where you're like, ostensibly modifying a file, but you're performing the null modification. And the weird thing about this is that if the upload is considered complete and immutable, then arguably any patch should fail. I think there's a tricky question here about what a zero-length patch does to the metadata of like the M time, basically, of the uploaded file. So I think this is an interesting problem, but I wouldn't want to jump to the first solution that seems to work.
Maybe to briefly clarify, the zero-length patch includes a signal that the client thinks the upload is complete. So it mirrors how the client completes the upload. And that is basically where the zero length patch comes from.
Okay, that's interesting. It doesn't sound very much like patch anymore at that point, though. So I wonder if that's really the right method.
Kazuo?
Kazuhoku, I don't have a strong opinion regarding these two approaches, but regarding if we need a generic solution, my understanding regarding resumable uploads is that we intentionally agreed to not make a generic resumption scheme for HTTP and focus on the uploads case. So I prefer something minimal. I think that's my high order point.
And Mike?
Mike Bishop, not as an AD. I'm just observing that for the question of a generic solution for post, isn't this a generic solution for post? That if you send the entire request up front and then you have to wait and you don't see the response, the server could just send you an interim response that says the answer will be available using this resource whenever I get around to it. And if you miss the response, you can go back to that resource. And if you get the response, you never need to use it and the server cleans it up later.
Just to clarify, by interim response, you mean creates a resource, basically, not a 1xx.
Well, it creates a resource, and then there's the 1xx that advertises it immediately.
Oh, okay, and then tells you about it within a week.
Yeah, the same way that you would if you were going to do a giant upload. This can just as easily say, well, the upload is small, but I know the processing will take 3 minutes.
That's true. That's quite a good take. Okay, so I think we have to brainstorm a bit more about this, but thank you all for the input. I think we have to keep discussing this. One of the next issues that were brought up during the last call was about GET requests. The RFC 9110 clearly couples head and GET requests, basically saying that the response for a head request is whatever the GET response would be without content. In our draft, we make heavy use of head requests to synchronize state after interruption, but only define what the head response should look like without ever talking about GET at all. And this is a bit odd, since head is more defined as GET. So the question arises whether we should talk about GET requests and their responses to upload resources in the draft. Just to make sure, we don't want to get into the area of downloading. Like downloading the representation that was uploaded is not what we want to do, but just talk the minimal that we have to about GET in the draft. So the proposal is to kind of say, okay, if an upload resource receives a GET request, it should just generate, hopefully, a successful response with all of the upload headers that would also be in the head request, or the response to the head request. That way, the head and the GET request, or the responses for head and GET are in sync again, and this all aligns well with the HTTP semantics, without getting into what the content for GET responses would look like. That's completely up for the application. They can do whatever they want in there, but we just care about the headers should be the same for head and GET. So yeah, is there any concerns regarding this from the working group, or do you think that this is fine? We can go ahead with this.
Any comments?
Doesn't seem like any. Then I will just continue. All right. So this one is about whether the offset can jump forward. And this is a point that has been brought up by one person trying to implement this. The offset is defined as the number of bytes that the upload resource has received. Kind of, yeah, how much of the representation the resource already got. This is normally that the client transfers bytes to the upload resource. However, the question is, can it also increase when the representation is filled in from other ways? So for example, there's one use case where the representation is hashed before the upload begins, and then the client sends this hash to the server as well. And if the server recognizes this hash and it already had parts of this file uploaded before, it can fill in the new upload as well. Therefore, from the client's perspective, the offset would jump forward without it actually transferring any bytes to the server. And the question is whether this is really a use case we want to support explicitly. Right now, it's not forbidden. You can do it, but the clients are not required to follow such forward jumps. Although it would enable some more niche and advanced and specialized use cases, such as the one from before where the server fills in upload bytes from another resource it finds. And this is the question to the working group, whether you think that this is out of scope for this document, whether this is too niche, or whether we should make sure that interoperability works here and require clients to follow such forward jumps if possible.
Mike?
Mike Bishop, again, no hats. So I would kind of reframe that a little bit. In that case where the client is sending a hash and then it gets filled in because the server also has access to that resource, the client did upload those bytes. They uploaded it by pointing to the hash and saying, use that thing. It's out of band, just like some of the out of band content encodings we've talked about for server side. So I think if we think about those cases as either out of band upload paths or a distributed client where there are multiple pieces, instances that are uploading pieces of this, then this becomes simple. If the distributed client sees a result that it does not understand, the upload has to fail. If the client is in multiple pieces and it knows that something else could have uploaded some of the bytes, then that's an expected outcome and it's just continuing the upload as normal. I don't think we should forbid this, but the details of how you implement a distributed client are not part of this draft.
All right, that's a very helpful perspective. Thank you.
Lucas Pardy, Cloudflare. So there's a question in the chat about concurrent uploads from different things, and that's something we've been very clear we don't want to. We want to keep this protocol as simple as possible, but I think we need to accept the reality that weird stuff's going to happen, and the client needs to deal with some of that, such as an offset jump. If we try to ignore reality and replace it with the client's own reality, I don't think that will be successful. So I think we should address this. I haven't been able to track the discussion. Sorry, Marius, but yeah, it seems to me like we can make the right wording without treading into the territory of kind of reevaluating our choice of keeping this simple and as serial as possible. Cheers.
Thank you. Yeah, let's try to solve it that way. Thank you. All right, let me get to the last one. Otherwise, unless there are any other comments, this about granularities. This is also feedback we got from people trying to implement the draft with existing infrastructure that they have. And they found that some legacy storage systems require data to be appended in certain granularities. So for example, this data can only be appended in multiples of 50 megabyte chunks for whatever reason. And when you try to build resumable uploads on that, you run into the issue that resumable uploads allow you to append data in whatever size you want to. That's basically the client sends it, and then the server hopefully accepts it. If you have those granularity requirements, you can implement this by basically discarding any additional data. So the upload resource would discard the trailing bytes to meet the granularity requirement that it has. This works, but is a rather implicit approach because the client never really knows that those bytes are discarded, and therefore they have to be resent afterwards. So this works to some degree, but to make it more efficient, we would require an explicit consideration for ending granularities in this draft. Basically that we talk about it in text, but also have limit values to communicate those granularities from the upload resource to the client. And the question is whether we want to support this explicitly or rather treat it as an implementation problem for the server, like that they have to figure out how to do it on their side. Is there any feedback on this? Any preference from the working group on this?
Lucas Pardue, Clive Blair again, also an author on the draft, in case people weren't tracking that. But I don't do as much work as Marius, so thanks. This, just to be clear to folks, this is effectively a brand new feature request, just as we declared that we thought we were ready for working group last call. Obviously, we're working through issues and editorials related to the kind of starting point of the design. My personal opinion is that this is an interesting thing. Maybe some people have use cases, but that we could potentially just punt on it, in that the way that we've designed the upload limit headers and some of the kind of requirements on how to deal with those, that we could fit this in later if we got some deployment experience. We do have implementers of this draft who've come with this feature request because they're mapping an existing resumable upload scheme and kind of migrating to this new thing, which is great. And that's an existing feature that they have. But my kind of gut feel here is that we should just say, not for now, thank you, and kind of gather a bit more deployment experience.
Thank you. Yeah, I'm also reading that from the chat, just for the record.
Yeah, Austin, I think the implicit support is sufficient.
Thank you. That's very helpful. That's all I have for now. Thank you very much for the input. We'll continue working on this issue and integrate the feedback, and then hopefully continue with this draft forward very soon. Thank you.
Thank you, Marius. That was good. That seemed productive. Next up, we've got Unencoded Digest. Lucas, do you want to talk us through where we're at?
We don't have slides, right? No. Good.
This needs slides.
Yep. I don't have slides. We have 0 open issues. So I think, I'm ready.
You're ready?
But
bring it on.
Yeah.
Okay.
Thanks.
Who's read this draft recently? Show of hands. Okay, we'll change that. We'll do a working group last call. Everybody take a look.
Who is going to read this draft shortly? Thank you. Thank you.
Thank you.
All right. You know who you are. Thank you. Much appreciated.
Thank you.
We will take notes. Thank you, Lucas. Secondary certificate, we're going to punt to the end, right?
Yeah, dude. I don't know if
Unless
Eric is online. Yeah, Eric Garbati's on. Do you want to talk through your slides?
Yeah, sure.
Great. Go for it. Just request permission. I'll grant it.
Alrighty. Let's have a quick chat about the secondary certs draft. So as far as the current status goes, some may recognize this exact slide from the last IETF. Kind of the only main non-editorial issue that's been sort of still up in the air is the whole support for authenticators in multiple frames over H2, and there's still some editorial work and passes to do, but nothing crazy there. On this issue, ultimately, several alternatives have been discussed here, and all of them add a lot of extra complexity for what seems to be a somewhat likely path, as in, I have not, spoken to parties who are in.
You're a little choppy, Eric. We're having trouble.
Oh, am I?
Yeah.
Okay, let me try changing.
Yep. And just go slowly.
Uh-oh. Huh.
Let's give it a couple seconds. All right. You seem to be back.
All right. Can you guys hear me?
Yes, we can.
Very well.
Great. All right. Let me continue. Yep. So, yeah, we've discussed a lot of alternatives, and every party that I've spoken with, who's interested in this, seems to support H3. Now, of course, there's still kind of the issue of UDP constrained networks and whatnot. So, discussion did ultimately lean toward essentially just closing this issue with no change, and kind of letting the issue, or letting the mechanism just be kind of a little more limited for HTTP2. That said, Martin Thompson did astutely point out last time that it is actually possible to adjust the HTTP2 frame size if needed. So, technically, if you had any party that was sending exported authenticators that were really genuinely too large for the default maximum frame size, this is something that can be negotiated. As for the head of line blocking, to some extent, I don't. It seems kind of reasonable to say that, yeah, I mean, it sucks, and it's more reason to use H3. Also, if I put my QMux enthusiast hat on, technically, you could achieve the multiplexing by just interleaving the stream frames at the QMux layer. Anywho, taking that hat off now. Yeah. So discussion ultimately kind of leaned toward essentially closing this issue with no change. We need to check with the working list or with the mailing list, but I thought I'd just sort of get a general vibe check with the working group about whether we feel okay with this or whether it's worth continuing to look into it.
Alessandro Ghedini, Cloudflare. Yes, definitely just close this. It would be unfortunate if this turned into another continuation sort of situation, which rhymes, I guess. But yeah, just close this.
Thank you. Corey, would you like to share your vibes?
Corey, unreformed HTTP2 apologist. Just close this.
Definitely getting the sense we don't like the continuation situation.
Yeah. We don't want to continue the continuation.
Ooh, he did it. He went there. Okay.
Yeah.
Any other feedback? Okay. Sounds like you've got an indication there. But
All right.
Say, take the list, but yeah, that seems like a good direction to start with.
Yep.
And so with this, we'll be close out on issues, and I imagine we can start trying to process last call here.
Yeah. I'd say check that on the list, produce a new draft, do the editorial work you feel is necessary. We can even start the working group last call in parallel with some of the editorial work if you like. But talk to us and we'll get that going.
Yep. Well, yep. You guys got ahead of me in terms of what I had for the next subset. So.
Sorry.
All good. Yeah. So I mean, it seems like we have a reasonable plan here. Just close it, do the editorial pass, and then I guess we can see where we go from there.
Sounds great.
Cool.
All right. Thank you, Eric, and thank you for the unusual time.
Yep. Thank you, everyone.
All right. So I think that's all the discussion of active drafts that we had scheduled. We do have a couple other drafts active, but we weren't in a state to have a useful discussion of them. So next up, sorry.
Do we have anything on the cookie?
Oh, I'm sorry.
Yeah,
I'm like I said, I need more coffee. Cookies. Yeah, we're yet again revising the cookie specification. I can't remember a time when we weren't revising the cookie specification.
Was there ever a time?
Really
Yeah.
sorry, Mark.
All right, let me get the clicker. Here, you can pass that to me.
Yeah, I just am I close enough? Oh, thank you. Actually, yeah, is Amajad on the call? Amajad, are you here?
I'm here.
Okay, perfect. I'm just gonna say a couple words and then
So-
you can take
Johan?
over for.
Sorry, Mike, you had an interrupt?
Could I just jump in and give an update on the previous cookies update?
That'd be great. Yeah, thank you. I was
So
gonna mention
it
but-
was approved by the ISG like 6 months ago, and had a couple updates that needed to go in before it could actually be sent to the RFC editor. But the primary editor has been on a hiatus for a little while. That is resolved. The updates are in progress, and we expect it to go to the RFC editor in the next week or so. And so hopefully actually hitting RFC, I don't know what the delays are looking like these days, but like early next year, or maybe even end of this year. We'll see.
Will it be below or above RFC 10,000?
I do not place bets on that.
We'll talk after the meeting. Yeah.
Awesome. Cool. That resolves one of the two things I wanted to mention. Thank you so much. But yeah, that was a much more complete update than I could have given. So there's some progress, some good progress currently on the old cookies draft, 6265biz. And what we're talking about here is the new cookies draft, which is layered cookies, which builds on top of 6265biz. As a brief reminder to improve how we integrate with browser specifications. Overall, like it slightly refactors things around cookies to give authority on browser side over things like same site, which are really just browser specification mechanisms that are not really needed on the Ietf side. And a bunch of, obviously also enable a bunch of new things, one of which Amajad here wants to talk about, which is origin-bound cookies. Before I'll hand over to Amajad, though, I wanted to mention that there was the HTTP only prefix proposal from Ietf that was presented, I think, at the last ITF or the one before. And I think that's the main change that we had in the spec up until this meeting from last time that I was merged and had a few improvements also go in. Feel free to check it out. I think it's a nice addition. So there was plenty of discussion before on that, so I'm not going to repeat it, but yeah, please do check that out. So briefly on origin-bound cookies, this is a new draft proposal that was just sent to the mailing list, I think early last week. I agreed with Mark that we can just cover it as part of my time here because I don't have any big other updates on cookies, except that we're chugging along, improving things on the integration side with browser specs. All right, I'm handing it over to Amajad. I'm also going to sit down.
Okay. And we can
Amajad or
Yeah, I can transfer
Oh, okay, good.
control.
Cool. Thank you.
Let's see.
Okay. 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 Hi everyone. I'm Rajot. So I'm gonna be presenting on origin-bound cookies, and this is a new draft, as Johan mentioned. So a quick overview of origin-bound cookies. It's a mechanism that updates the layered cookies, and the main about origin-bound cookies is we aim to enhance cookie security by binding cookies through their port and schemes, which they are set on. And this addresses a current weakness in cookie confidentiality, where cookies are not scoped to the origin that they're set on by default. So here's the current security vulnerability that I mentioned. So cookies currently have weak confidentiality. So an attacker can read sensitive user data set by a secure site if it is unintentionally sent for an insecure site. For instance, if https somesite.com sets a cookie, an attacker could try to trick into visiting http somesite.com. And the main difference here is a secure site versus an insecure scheme. And the browser would then send the cookie, allowing the attacker to intercept it. And the also security vulnerability that origin bound cookies covers is weak integrity. So an insecure site controlled by a network attacker could set a malicious cookie and that is sent to the secure version of that site. So this is on a different port. So if someone sets a cookie on HTTPS some site and the port is 300 and then the attacker compromises it with HTTPS some site 345, it would send because currently cookies are not bound by this. So as I mentioned, the solution here, we have the solution is two parts. So first part is port binding. So this is updates the cookie struct and it alters it to include a port attribute, which binds the cookie when it is set. So an example of this is now a cookie set by https example.com will only be set to https example.com with the port 443. And now when it goes to a different port, like example https example.com 8443, it will not be able to access it. It's bound to 443 now. And then pre-existing cookies in the draft, I mentioned pre-existing cookies will have null that don't have the port specified already because port specified will be from new cookies onward. So those will be treated with the current cookie behavior, like legacy behavior. They won't be bound, but anything with the port set and onwards will be port bound. Similar for Scheme. Scheme is also, so now it's bound by if https example.com sets a cookie, http example.com will not be able to access this cookie. And similar to port binding, that anything with an unspecified scheme it will be treated as null, and then it will be treated with how the current cookies are being operated. So it's from anything with scheme set and onwards. So some security considerations. Overall, this is a pretty net positive for security, I would say. For clients that require use of cookies across origin, there is a sort of behavior built into origin bound cookies that allows for some relaxing of like the bindings. It's not as strong bindings. So if a cookie has the domain attribute set, which we call a domain cookie, then port binding behavior will not be enabled at all. It will just be scheme bound and it will not be port bound. So yeah, and importantly, domain cookie is still bound to the scheme of its setting origin and port is ignored now. And this allows developers to opt out of stronger protections from origin bound cookies, which can help with like compatibility issues if they need particular cookies across host or ports. And finally, origin bound cookie will obsolete the purpose of the secure attribute, but the proposal in the draft does not remove the support for it. That's probably something that could be future consideration for the HTTP working group. And yeah, that's all. If any questions or
got David Benjamin.
David Benjamin. Oh, this is working. This is great. We should do this. This fixes one of the original sins of the like cookie header. In particular, the like although you can kind of work around the scheme bound the lack of scheme binding with like the secure attribute and the underscore secure prefix, everyone has to remember to do this. This also removes one of the things that we are currently leaning on the HSTS list for, because HSTS is not just to like keep users from accidentally visiting the HTTP URL. It's also so that you can't use the HTTP URL to attack the HTTP origin to attack the HTTPS origin. But giant lists of domains are a huge pain for everyone. So if we can just have the platform do the right thing, then like HSTS is a little less important and we can breathe a little easier.
Okay. Any other initial reactions? Do people share the enthusiasm?
I share the enthusiasm. No, but seriously, I reading, listening to the entire presentation, my thought is, I really wish we had done it this way the first time, right? Like, I wish you could make the default the opposite direction and make it opt in the other direction, and I realize why you can't, but it makes me sad.
Yep. So many things about cookies fall into that bucket, I think.
No.
Okay. So this is promising. It sounds like the editor should start to work on incorporating this, so the working group can consider it in situ in the new draft. So please continue, I would say.
Okay. Yeah. Thank you. Thank you, guys.
Thank you. Thanks for the explanation and the heads up. Any other cookie thoughts beyond the general sense of sadness? Okay. All right. Well, thanks again for the work. We do appreciate. We know it's a long slog with the cookies, and it's actually quite gratifying to see the baton being passed from groups of editors to group of editors to continue to maintain this thing that we've been stuck with. So thank you. Exactly. Yes. Spread the load. So I think now we're done with the currently adopted drafts. So let's move on to Yaroslav and detecting outdated proxy configuration. Clicker. Thank you.
Good morning, everyone. I'm Yaroslav from Zscaler, and today I would like to present second iteration of detecting outdated proxy configuration proposal. As a very quick recap, stock proxy configuration is a problem. Today there is no push mechanism to send an updated proxy configuration to the client that can lead to certain disasters if you have made a mistake in your proxy configuration. So all the mechanisms that we have are pull mechanisms. So when client just periodically fetches a new configuration and when the previous one expires because some kind of header or PUD config was set. So the proposal is to include a header from the client side that would tell the proxy what is URL, if URL is applicable, of proxy configuration source and when it was fetched, so fetched timestamp. And URL may be omitted if proxy configuration is fetched from the default PVD location. And then on the other side, proxy may signal to the client proxy config stale header with Boolean value. So it could be either true, meaning that configuration is stale and client needs to refresh the configuration, or false, meaning that configuration is known to the proxy and it is not stale. And if proxy doesn't know anything about this particular client configuration or doesn't know about this specification, it won't include the header. So few changes that I've made in the second revision based on the initial feedback from the working group. First, allow this mechanism only for connect, where there is a very clear separation between headers that are intended for the proxy and headers that are intended for the origin. So the mechanisms that do not proxying mechanism in HTTP, somewhat legacy mechanisms, one could say, that are relying on absolute form URI of HTTP 1.1, they still exist. They don't have clear demarcation between headers intended for proxy and headers intended for origin, and we don't want proxy configuration information to be leaked to the origin. It may have all sorts of privacy and security negative consequences. So the proposal is to restrict that just to proxying methods that include connect method across all HTTP versions. And I've also added relevant security consideration. The second change is one of the feedback was there were more reasons to omit URL by the client. So not only when client fetches proxy configuration from the default PVD location. So for example, when client has proxy configuration somehow pushed by a management system, or something else could have provided the client to with the configuration. There is no URL associated, so that's another reason why URL might be optional. So absence of URL does not automatically imply that client fetched it from the default PVD location. It could be just not associated with a URL at all. One question proposal, there were two additional pieces of feedback from the last time that I have not added into this draft. One, the ability of proxy to provide a different location of proxy configuration. Personally, I feel that it's a bit dangerous because it can have all sorts of security problems, like proxy being rogue and giving to the client very wrong configuration that would leak requests somewhere where it's not supposed to be going. I think that's quite dangerous ground that expands this specification to areas that a bit outside of initial scope. And second question, I don't have strong opinion on. Should we introduce a new proxy status header, or sorry, new proxy config stale header, or should we use a new parameter within a proxy status, existing proxy status header? I'm not a big expert on proxy status header. Based on what I've read about it, it feels that it's mostly focused on reverse proxies, not that much on explicit proxies. But if I'm not correct, then I'm happy to change it accordingly.
Right. Yeah, I don't have the client up. My initial reaction to that is that proxy status, it's not about reverse proxies only, it's about any it really should, and we talked about this when we did it, really should be intermediary status. It's not specific to any particular kind of intermediary, but it is focused on the status of the intermediary. And what you're talking about, my initial kind of reaction is what you're talking about is more about the state of the client. And so it seems like that's not really an appropriate place to put this information. I think probably your own header is more appropriate. But I'm willing to be convinced otherwise.
Okay, like I said, I don't have strong opinion. I'm happy either way, but yeah, would be good to settle that and move on.
So Tommy, probably speaking as an individual, even before you got to this slide, I was thinking, what about the proxy status bits? Like in experience for Connect style proxies for some of the use cases I know you're working on, I'm definitely aware of using proxy status fields, and there are things that we had added, like adding information about how a Connect proxy had done resolution upstream and telling clients about that. There are also proxy status parameters around like proxy configuration errors that you can say, oh, I had some error in my configuration, etc. So I think it could fit into there. It's something that clients of Connect proxies can and do already parse. So I think it depends potentially how that parameter is phrased. If it's saying you are stale, that sounds like a different header, and that sounds like something about the client. If it is instead saying, here is when my configuration was last updated, or like something that the proxy can just declare, which could still have the same effect for the client, then putting it in the proxy status would be nice. So it's a bit of just a how do we want to design it thing. I think it's a worthwhile problem to solve. I think we can iterate several times with the working group around how to spell it. I think Ben is next.
Ben?
Hey, I think to me the interesting question here is, are there open deployments that need this? like, is there a reason that we need a standard here? Because we're talking about some pretty detailed control plane stuff that is normally not really done through a standards mechanism. The question of like, is this configuration stale, is kind of like a pretty detailed sysadmin kind of question for a deployment that I wouldn't expect to have a standard protocol for. So the point where you need a standard protocol for this, I think, is where you have clients and servers or clients and proxies interoperating that are not from a single vendor controlled by a single entity. And so I think the question for me is, do we have that? Do we have the interest or a clear deployment where we have that kind of mixture of vendors?
Well, in my personal experience, yes, very much so. People do still use very much pack files between different proxy vendors and between different client vendors, and PVD configuration that is right now going through last call at inter area, also supposed to be very much vendor interoperable and providing some suggestions how clients can fetch proxy configuration from standard locations. Yes, that in my experience, that problem is very real.
Okay, thank you.
Jim Taft, coming from Broadcom, coming from the same world as Yaroslav. This definitely is something that needs to be done. There are a lot of use cases for this. The multi-vendor situation is exactly one of the reasons, but also clients tend to fetch pack files way too often, and this prevents that problem. You have 5 or 6 agents on a machine that are checking every, 15 seconds times 100,000 users. It's bad. So, and they're, 500K files sometimes. So I think this is needed, and I think that's great work.
Thank you.
And just to continue a thought about the proxy status versus proxy config stale, to me, this feels a little bit like some situations we get into with the link header, where people, are creating a new protocol and they say, "Oh, look, the link header's already there. I'll use that because I have a link." And it's like, well, yeah, but now your clients, the other participant in the protocol needs to parse through potentially many different links because everybody dogpiles onto one header because it's already there, and that's not a great situation. If it's a distinct protocol, that is different than this kind of informational thing, which is proxy status. That's more of almost a debugging kind of tracing sort of thing. Then it probably should be a separate header. We shouldn't be scared of creating new headers, especially now that we have wonderful things like structured fields. This is a paid message.
Thank you.
You're paying? Yeah.
Who's paying? And my second question, what are the next steps? Is there appetite to adopt this work and make it official working group item, or do we need to go through a few more iterations?
My gut reaction is that, certainly this is a little bit niche in that, forward proxies are not as common as they were on the open web, internet back in the day, but they're still part of the architecture. There are still valid use cases. Those use cases are a little different. And so I'm not surprised that maybe the response is a little muted, but it does sound like there's an important kind of contingent. I personally, I haven't talked to Tommy about this, but I'd be willing to go ahead and do a call for adoption and see how we go.
Thank you. Yeah, and there is also this thing called Mask.
Yeah.
Which there is also this thing called Mask.
Oh, those
I'm not
people.
sure if you heard of it.
Yeah, they're very enthusiastic. Yes. Okay, I think we'll probably go ahead and plumb the depths, see how it goes. But yeah, it sounds like you've got at least some interest here. So
Thank you.
And next up, we had your other presentation, didn't we? Yep. Let me get it. Unbound data frames in H3.
Okay, and now to something more controversial.
Now you.
Okay. Unbound data frames in HTTP 3. Optional, that's an important thing. Optimization to reduce optimization complexity. So before I dive into this, this idea came up many times. to my knowledge. So last time it was brought in some web transport development conversation when some people developed web transport and realized all sheer encapsulation complexity they have to deal with. I know that some organizations, some proprietary implementations of HTTP3 use this sort of optimization in their proprietary environment to squeeze a little bit more performance. And as far as I know, this was discussed when HTTP3 was originally designed back in the day. So what this is about now, in HTTP3 we have data frames. So after headers are complete, then the data is encapsulated inside data frames, and the only practical purpose of data frames today really is to indicate when data is complete and trailers begin. So the segmentation of data frames has nothing to do with segmentation of underlying data. So if you're having capsules, they could be separate. You could have web sockets segments, you could have TCP segments, you could potentially have all other protocols, and they need to take care about their own segmentation because data frames do not correlate to segmentation that you want to accomplish on lower protocol layer. So as I tried to illustrate there, so the internal segment of a protocol that you're encapsulating in HTTP doesn't align with data frames. You could have one, you could have 1.5, you could have more than one. So it's a little bit weird. So the drawbacks of data frames as they exist today, they are, well, one could say, kind of useless if trailers are not in use, which is vast majority of situations today. They do add a little bit of or some overhead. I'll talk about that in just a moment. They do add complexity, especially if you're implementing the whole stack, then you need to take care of all these lovely layers. They create unnecessary state, so you need to track when frame starts, when it ends. They add a little bit more complexity when it comes to APIs. So ideally from your HTTP3 library stack, you want to stream data, not buffer until the whole frame is complete and then wait for the next frame. That will create some unnecessary latency and buffering. You want to stream data through and take into account when frame ends and make sure that the next thing is the frame. So it adds quite a bit of state, and not HTTP3 library have the necessary language instrumentation to deal with that complexity efficiently. And inner segments must still carry their own length. So the fact that we have a data frame with a certain length, you still need to encode your own length if you're segmenting data inside. So such as capsules carry their length, WebSocket segments carry their length, and what other things as well. So the proposal is to introduce an optional and bound data frame, which is a simple zero length indicator, meaning that the rest of quick stream is just data. This is an optional capability that is negotiated through settings. So if you don't want to use it, don't negotiate it. We are not stopping people from using regular data frames. If you're planning to send a trailer, then don't use it, because you will not be able to send the trailer if you are using unbound data. And unbound data can be sent at any point in time after the header. So potentially you could include, if you feel like it, regular data frames, and at some point decide, I'm not going to send a trailer. The rest of the stream will be just data. So sending this unbound data indicator, which is a zero length frame, and then the remainder of the stream would be treated as data by the application. Or you could send unbound data immediately after headers, which I would expect, if this goes forward, would be more common pattern. So how much does it save? It really depends. So the worst case scenario, the least kind of saving scenarios, just could be as little as 3 bytes per frame, which is nice, but not much. But in certain scenarios, it could really help to avoid unnecessary memory copy. So I have to make a confession. I'm one of those hooligans who use hypertext transfer protocol to transfer things that are not hypertext. And in certain cases, I want to do that very, very efficiently. And some people go to great lengths to avoid memory copies or to make as little memory copies as possible and arrange packets in vectors and do all sorts of interesting things to get to high performance. And one common technique is to try and reuse packet buffers across stacks. So for example, if I manage to get an original TCP packet in my zero copy framework, I have an IP header, I have TCP header, and let's say I want to encapsulate that packet, to send that packet in the data of this packet, I should say, in a connect stream. And let's say I'm lucky, there are no TCP retransmits or reordering, so I don't really need to do anything other than copy data over into quick stream. Then obviously there are loads of variables here. In some cases I can be lucky and my header buffer is enough to just reuse it to encode UDP header, quick short header, quick stream header. But the H3 data header might actually make a significant difference. It might add just enough for me to have to do an extra memory copy because my headroom is not big enough to encode all the things that I want, that I need to encode there. Now, there are obviously no guarantees here because there are loads of variables. You have connection ID length, you have all sorts of variable length encoders. My source could include all sorts of lovely TCP options or not include them next time. IP versions might be different, but still there are cases when absence or presence of these few extra bytes can make a difference. So some questions, there was a discussion on the list, enthusiastic discussion. Some proposals were made, some questions were asked. I'll try to summarize some of the questions there. So there was a proposal for a capsule frame type. So maybe we don't want to necessarily break HTTP3 semantics that badly and have a capsule frame types. I actually started drafting that proposal to see what it would look like and run into a few issues. So first is capsule frame would require transformation from regular capsule unless you want to encode length twice, which doesn't really, again, brings us back to territory of sending unnecessary data. There is a proposal out there for unbound capsules that obviously won't be possible if we ever do capsule frame in HTTP3. And yeah, finally, there are plenty of things that are not capsules. So the good old connect is here to stay. I don't think there are any plans to deprecate that. WebSockets still very much exist, and they are standardized for HTTP3. Second question that was brought up, does it contradict RFC 9114? Do we need to update RFC 1994 with this one? And so far, again, mine and David's read is that actually not. This is still a valid extension when it comes to RFC 9114. Even for connect method, RFC 9114 gives us escape hatch saying that extension frames may be used if specifically permitted by the definition of the extension. So we don't have to use only data after connect. We can introduce potentially our own thing without triggering something in Internet Police. And why not send zero length data as a marker? That could be possible, but apparently there are some people who misuse zero length data frame for other purposes, such as sending keeper lives. So that would mess with them. Yeah, that's now too late to do that. We really need to introduce a new frame type to not break compatibility if we want ever to do unbound data. So that's the proposal. Any suggestions, thoughts, comments?
Corey.
Corey Benfield, Apple. I'm sympathetic to this use case. I see where the value would come in. It does feel like another step towards HTTP as general purpose transport for everything else. Particularly the RMing of trailers out of this starts to get a little weird for me. I'm not fully convinced yet that the win is enough to justify it, but I think I could be convinced. So I think if we could find a way to make that case a little bit more compelling, that would be a little bit more interesting to me. But I'm a little nervous about removing the trailers.
Yeah. That's good. Ben?
Hi. So I think this is a fun problem to think about, and if we can come up with a solution, I'm potentially supportive of doing something here, but I have concerns about this specific solution. So it's not just that this isn't supportive of trailers. It's that you have to figure out whether or not you need trailers at the beginning or at some early in the request lifecycle. And most HTTP implementations don't know this. The request comes in and they only find out at the end whether or not trailers were going to be needed or not. So the result is that this proposal as it's structured can only be used in some very narrow use cases where everything is known in advance. And by the way, trailers can even be useful in proxy context. The proxy status header is also usable as a trailer. So another example of, I know that trailers are a pretty marginal use case, and so it seems like, well, whatever, we don't need trailers. But another important use case for trailers is gRPC. And I think gRPC is a case where there probably are a lot of potential benefits here. I bet there are gRPC streaming applications that send a few bytes at a time, dribbling out a response that could really benefit from this, but can't use it because gRPC depends on trailers. Another thing to think about here is that if you really need this, we have web transport. Web transport already gives you this. It gives you the ability to slice out the HTTP3 framing layer entirely. And since you need to know that trailers aren't being used, you already need application level integration of some kind. So this strikes me as sort of an uncomfortable middle ground between HTTP and web transport in that way. So on the mailing list, I floated an alternative implementation that I think basically gets the benefits that you're looking for here without the downsides, which is to indirect the data onto a new quick stream. So this quick stream, the data will be over here on this other quick stream, no framing. And then you can continue to send other frames on the request stream, which is now kind of a request control stream. I'm sure there are other ways to do it too.
Okay, thank you. That's very valuable feedback. And yeah, this is something that I'd be very interesting to explore. Thank you.
Alessandro Ghedini, Cloudflare. So I'm not necessarily against the idea, and I sort of understand where you're coming from, but it also seems like it's actually just more complexity because you still need to implement all the other cases anyway. And then you add on top the logic of, oh, now I need to decide if I want to send unbound data or not. And the performance improvement, like I'm not entirely sure that necessarily justifies the additional complexity. But I might be wrong. Like it'd be nice to see like actual maybe data if you have it. But yeah.
Okay, thank you.
Alan?
Alan Frendel. I think this is fine. I'm sympathetic to the trailers problem a little bit and not necessarily knowing upfront if you're going to use them or not. So the use is kind of niche, but I mean, you sort of had me at it's an extension, and if you don't like it, don't negotiate it. And if you want to send trailers, don't use it. That being said, probably the people in the room need to see like maybe some implementation or like interoperability experience to be convinced either of the performance benefits or that it's not all that harmful. With respect to the idea Ben mentioned about like, I want to say it was Mike's proposal years ago. We were talking about H3 and like, oh yeah, we can put the data on this other stream. We can talk about it again. I think like now that we have like the world of web transport, like I don't know that we want to go there because I find that to be even more an uncomfortable middle ground between what we have and web transport. So I don't know. I think you should keep going here.
Thank you.
Katsuhok, so regarding the use for generic HTTP, I'm not sure if we have enough information to reconsider, but we agreed during developing HTTP3 that all the responses should be framed. And for that, it's not just about trailers, but it's also about push promise. We already have it, and there are all other possible extensions that we might define. That said, I think one of the reasons that we have to have this discussion is because the draft is currently framed as a generic extension to HTTP rather than a way of skipping frames when connect method is used. So maybe reframing the draft to say that when you negotiate these settings, then once a connect tunnel is established, then the rest of the streams no longer have the framing thing. So maybe like if you frame like that, then it becomes specific to connect, and then we could probably avoid the discussion of if this is good for generic HTTP3. So I think that's one of the directions.
So sorry, just to make sure that I understand, you're suggesting that you're saying that it would be, it should apply only for connect. It shouldn't apply for other HTTP things.
Right,
like it's only
right.
for people who don't do hypertext.
Right. So exactly. Oh, so the conceptually framing it as a frame is the problem. That's my point.
Okay, thank you.
So I like your suggestion a lot of framing this as a Connect specific use case. However, Ben triggered me by mentioning gRPC, which reminded me this can't work in H2. And so its use with gRPC is moot because gRPC,
this is strictly H3 only. So.
Right, and so that raises the other question, which is I've lost track of where this working group stands for things that only work in one version of HTTP, but we should bear in mind that this is a thing that only works in one version of HTTP. It simply cannot work in H2.
Do we have anybody else in the queue?
No.
Oh. Great. Well, thank you. We will reconvene and perhaps make a next new revision for the next meeting. Thank you.
Yeah. Thank you.
Thank you. Finally, Eric, you're with us? Great. We've got Eric Nygren on HTTP 1.1 request smuggling defense using cryptographic message binding. Another spicy one, perhaps. Yes. Eric?
Do you want to click?
Oh, thank you. So some of the context here is as much as we'd like HTTP 1.1 to go away, we're kind of stuck with it. But there do seem to be a ongoing stream of vulnerabilities that keep showing up with HTTP 1.1 implementations, especially request smuggling vulnerabilities that we've seen over the past, with a few of them showing up each year, oftentimes taking advantage of implementation differences between vendors. I kind of think of this as HTTP 1.1 is kind of in that similar bucket to C of we're stuck with it, we don't really like it, and some of the issues that show up with it, where you're kind of intermixing of hostile data with this thing that was designed not really to handle that hostile data, means that there's a set of protections that are needed in place, and there's no one single one. So I think there's some really good ideas that came out in the list discussion of things like having better conformance test suites, which you can kind of think of correspond to things that we do on the C side of having static analysis or other fuzzing testing. But similar to how C has, in the C world, we started doing things like address layer randomization and putting framing in front of and behind things. There's kind of like protections we start needing that HTTP 1.1 being able to fold that in might be helpful for. So request smuggling, briefly, there's a number of these confusion attacks. Request smuggling is one of them that I'll focus on, but I think there's a number for others that keep showing up that we may want to also look for defenses against. But in request smuggling, a common case there is you'll have a request inside of a request somehow. So you might have a normal GET request, a smuggled request somewhere, like in the body of it, and then something causes the different implementations of between an intermediary and a downstream server, like an origin, to get confused about things. So from the intermediary's perspective, it's just seeing this request. It doesn't know there's a smuggled request inside of it, and it passes this along to the downstream server. And the downstream server sees these, but it sees these as two different requests. And then the responses go back, and the malicious client kind of is not caring about this. It's trying to do something like either poison the cache of the intermediary, or get some data, or kind of get something through and bypass validation on the intermediary to get things through to the downstream server. But then the downstream server evaluates this, and in the end, you kind of end up with a situation where that smuggled request makes it through to the downstream server, and possibly poisoning the intermediate cache. And there's a wide variety of things that we've seen in different implementations that show up this, and like playing games with 100 continue and different implementation differences there, playing different games with different types of handling of different encodings, playing games with like duplicating headers or putting new lines and spaces and all these various things. The idea here is to look at how can we protect this. So in H2 and H3, we have that mixture of hostile user data and or kind of hostile data that might have come from a malicious client, and control stream data we separate out explicitly. So we have things like stream ID to keep track of which stream and request are things in ways that are totally separate out from the user data, or things like the meta information, like what is the host header or what is the path. We separate out and pull into length eliminated headers with pseudo headers that's really clearly separated out. But HTTP 1.1 doesn't have that. So the idea here is to have a in-band but protected signal to be able to get some of those same properties that you have in H2 and H3 in a way that you can detect when smuggling has occurred, and then have that downstream server or be able to hard fail when it detects that something funky is going on. So in a proof of concept proposal here, we put in a new request binding header, and that request binding header is kind of indicating a request serial number. And if the origin server sees a request that is missing that or has those out of order, and I noticed a typo in the slide, but then it can go and abort things cleanly or safely. So as I mentioned, like it would be nice to kind of follow through on some of the HTTP 1.1 must die and just get rid of it or start ignoring it. I don't think that's realistic, especially for some of the intermediary to origin server implementations. There are even quite a few things like origin proxies and reverse proxies in front of origins that might be facing things like a CDN that themselves will go and terminate H2 or H3 and then re-encode stuff into HTTP 1.1. And while we haven't yet, I don't know, like that having H2 in the middle might help a little there. There's still enough wiggle room anytime you go into HTTP 1.1 for weirdness to happen. So this draft here is really meant as a proof of concept approach for one way to do this, because I think and as a starting point for discussion, I think as discussed on the list, there may be other different approaches for how we might want to do this if people are interested in solving this. In the draft, we propose using TLS exporters as a way to protect that request serial, and which is kind of the equivalent of the stream ID, as well as to protect other information. But I think there might be, if there's interest in the working group pursuing this, there may be other approaches we might take to do this. So I think properties of a solution here to be worth doing is it needs to be easy to implement. And I think some of these properties came from feedback people gave on the list So I think it was helpful. The feedback already has been helpful, but I think it needs to be easy to implement and low enough overhead. Like if this is an overhaul of the protocol, or let's go switch over to a HTTP 1.2 or build some whole new thing, then the amount of work involved means that things might as well just move to H2. It needs to be needs to be something that can auto negotiate, so something you can just enable it as a drop in. Because ideally, this is something where if it's going to be effective, people need to be able to just upgrade to a new HA proxy or Nginx on their origin server and flip on something on the CDN, or have a CDN in the intermediary just auto negotiate that and have things just work between them with kind of because again, this is one of those, the higher the barrier of effort of implementing this, the less likely that it'll get deployed, and easier it would just be to switch to H2. And it needs to protect the request serials to be able to kind of handle some of these smuggling attacks. But then there may be other types of attacks in here around some of the things that are covered by H2 pseudo headers, which we may, but also we've seen attacks against, like path or host or authority, that we may want to protect against. And we want to protect against enough different attacks. And I think some aspects of that is it really does need some degree of out of band information that the attacker can't just simulate, because otherwise it's pointless. So this is where TLS exporters is one way to do that in cases where people are using some of these like reverse proxy situations that are using something like the proxy protocol. Like that can be another way to convey some of the context you need, the key, convey the keys. So I think kind of bottom line, is this a problem that people in the working group are interested in solving, especially implementers who have things on either the CDN side or as common origins that CDNs or other intermediaries face? And if so, like what is it? What path is this? Something where the working group would be interested in picking this up as a draft? Do we want to have some additional kind of iteration offline, or some in place like the HTTP workshop, and then bring something back? So thoughts, feedback, interest?
Corey?
I think this is probably worth picking up. I'm very sympathetic to the use case. Again, I'm personally sick of doing CV releases for request smuggling stuff. It's driving me nuts. I think we would need to consider one other use case, though, which is for some of the in data center type use cases, your ingresses for things like Kubernetes will not be doing TLS directly to the final host because they're already on the box. So in that context, they need some other way to communicate this that is appropriately bound, or we'll get ourselves back to where we were before. It might be enough to just say that's a trusted environment, and so we don't mind too much that there's nothing else bound there, but the draft should speak to it at the very least. Otherwise, yeah, I think this is a problem worth solving. I think we should take it up.
Yeah, and I think for some of those things where like the service meshes, that could be a case where it's worth solving for, but that may be one where conveying a key out of band, like configuring a key out of band, might be perfectly good enough.
Kazuhawk. So technically, I think we don't need a TLS export or something. We only need a hash chain to for each side to track what was sent previously and then what was sent next. But still, negotiation would be hard because this has to be hop by hop. But I think the broader problem, or the broader issue with this approach, is that it considers this as a problem of HTTP 1.1, whereas in my view, it is a problem of intermediaries that try to observe HTTP 1.1 on the side and make decisions while forwarding the strange bytes as they are. So, I mean, smuggling becomes a non-issue if you pass the request and when forwarding them, encode them based on your understanding. So for somebody who's done that and has been saved from the recent HTTP 1.1 must die attack, I'd say that it'd be unfortunate, if people still being stuck in the old dangerous way proposes these kind of band-aids rather than doing the right thing.
So on the on the first one, I think like the hash is what you'll need going forwards, but you need something to key that hash, because if you don't key that hash, then or have some way of keying that hash, then the attacker can just start the hash. So that's where the TLX exporter is really just a way to get the seed for that.
Yes, as I agree that seed has to be exchanged, but yes, it doesn't necessarily need to be TLS. It can be just a first header or something that the proxy inject.
Yeah, there's I think variations on that, and I think on the second part of this, I think the problem is we're kind of stuck in this world. Is we have a lot of it's like it would be nice if we weren't in this and we could say, and like I agree that that some of this is inherent in those, but we are stuck in that ecosystem, and one of my colleagues who've been researching this points out that even in the cases where you are doing conversion between things, anytime you have an intermediary that's doing conversion and has to support both HTTP 1.1 and HTTP 2 clients, you can still have HTTP 1.1 clients that come in that can mess stuff up for those H2 clients.
Yeah, if you are at semantic level, I'm not sure if that's the case, but thank you.
Sandra?
Alessandro Gadini, Cloudflare. So I haven't quite looked at the solution, but I do think it's a problem worth thinking about. I feel like there's probably going to be some, I don't know, strange edge cases to maybe think through. Like Ben was mentioning before, sometimes a connection starts as H3 or H2, then the intermediary turns it into H1, and then there's any number of H1 intermediaries, and then it turns back into H2 or whatever. So there's probably some thinking that we'll need to do, but I do think we should work on this.
Great, thanks. Yeah, and I think it is very much explicitly a hop by hop. Like there's a hop by hop solution. I think a bunch of the complexity does come from needing to have negotiations so that it really remains hop by hop, and so you don't get these leaking through to future hops.
Ben Schwartz. So I do think that this is an important problem. I would like to see the group do something here. I don't think that this approach, this category of approaches, is going to be very fruitful. This, the way I see this proposal is that it's something that either party can. It's negotiated, meaning both parties have to enable it for there to be any benefit from it. But the entire problem here is about situations where at least one of the parties is unable to update their systems to use a more modern approach generally. And so I think there's kind of an inherent tension there. It's very unclear to me how you would end up in a situation where you would do this. I think that I would be much more interested in a much more forceful recommendation that effectively says, if you're acting as an intermediary in a case where request smuggling attacks are a concern, then you shouldn't reuse HTTP connections. You should just disable HTTP 1.1 connection reuse entirely. That doesn't actually need to impair latency. If you're very latency sensitive, you can maintain a connection pool. And get exactly the same latency characteristics you have today. And we talked on the mailing list about a bunch of other kinds of approaches that you could have here. But fundamentally, I think one-sided solutions to this, solutions that don't require both parties to upgrade and add new capabilities, are much more interesting. Because if both parties have to add new capabilities, then they should just use H2.
Alan Frindell. Well, I can't disagree with what Ben just said. Yeah, use something else. Use something else. But if you have to use H1, this is a problem that, I don't know, when people ask me, like, what are the biggest risks? Like, what's the worst thing that could happen if your software goes sideways? Like, this is like, yeah, somebody sends 2 responses to one request, and then we start spraying, the wrong request, the wrong response to the wrong person. So I would love to see something here, even if it's between two willing parties. I think it decreases risk across the ecosystem. So I mean, on the sort of here to answer the last question, am I interested in solving? Like, yes, particularly if it meets the. I mean, I don't like messing with my H1 implementation, but like if it's easy to implement low overhead, like yes, I will do this.
And that's the end of the queue, I think. It sounds like there's definitely interest in continuing the discussion here. So
Mhm.
I'd say keep it up on the list. Let's see if we can carve out something that helps. My only response is I think Ben talked about using multiple connections. The problem there is that then you start having issues with slow start and congestion control, and it's not really optimal. But for whatever reason, people do seem to use H1 a lot on the back end still. And so this is a problem that's, interesting to solve from my personal perspective. Ben.
So on the back end specifically, I want to point out, we talked, for example, about single host use cases. Those are extra special, right? Like those are TCP connections almost in name only. There's no network. It's all in one host.
Yep.
So it's not clear to me that we should be worried about congestion control slow start when we're doing IPC on one host.
Yeah, I'm not thinking of those use cases as much, maybe, but yeah.
And it might be worth kind of splitting this up into two classes of things. There might be, I think there's a class of things that might be a set of recommendations that say these are some of the risks of HTTP 1.1 and ways to work around those with no changes in a one-sided way. But some of the downsides of doing those. But I also don't think that that some of these things like just stop using persistent connections are going to be viable for example, the CDN to origin case. And for those having trying to figure out what is the lightest weight solution that's the easiest to implement drop in that we can come up with could help a bunch with those without necessarily having to throw everything out.
Alan
Frindell. Well, the other thing I didn't respond to Ben's thing about connection pooling, but what I like about that idea is like part of a suite here, which is like there's H2, there's H1 that uses this, and there's H1 with no connection pooling. And so that's a little bit of a hammer to get people to, if you, look, you want to do H1, fine, but you got to do it this way if you want it to be performant. Otherwise, I'm turning your connection pooling off and it's going to be slow. And that will get people to a safer world. So, I mean, I don't know. CDNs and backends maybe don't have the same leverage, but at least internally, we'll probably wave that hammer around.
That's a good perspective. And if there are people who are interested in co-authoring this or kind of helping me run with this, please feel free to raise hands or let me know offline.
Sounds great. Thanks for getting this going, Eric. That's important, I think.
Thanks, and thanks for the time.
Thank you.
Yeah, thank you.
Okay. So that's all we have in the agenda. I wanted to mention one other thing since it came up. And I want to make it clear this is with no hats. We do hold an occasional side event, and by we, I do not mean this working group, I mean the community, called the HTTP Workshop. It's not an IETF event. It doesn't replace the working group. It's not a decision-making body. It's more of a discussion body. So if you're interested in the protocol, we've scheduled one for next year, the week before the Vienna meeting. You can find out more about that by going to httpworkshop.org. And so we'd be excited to see some new faces there. Other than that, I think we're done. Yeah?
That's good.
All right. So thank you all.
Yeah, thank you all. This has been a good meeting. We have some work that we're finishing up and some good things coming in. So appreciate the healthy discussion and engagement, and have a good rest of your week.
Thank you. Sorry, my joke about masks. Oh no, don't be silly. I wanted to run something by you. If you have minutes. So web bottles. No, sorry, not related to web bottles, but abusing web bottles potentially. So one problem that I'm facing in my current day job, and I was facing in my day job before and in my day job mentioned before, is multi-tenant proxies in the cloud can have difficulties when it comes to working with CDNs or contact providers. If you have somebody who's misbehaving behind multi-tenant proxy, or just because we have spiking requests and block or CDNs or the fact that yeah, that's unusual behavior, punish users with captcha, and we have to write some emails to somebody saying legit proxy, not punish us. And it feels to me that the mechanism that proposed with the could be potentially used for this.
So
I didn't
I've
bring
seen-
it up at the meeting because
No,
there
yeah,
are ranges.
I've seen use cases where is that like